Is your MIPS payment adjustment wrong? Promising results for bile duct cancer diagnosis, and a new guide to pharmacogenomic testing. These stories and more coming up next. This is Path News Network, Daily Edition from the College of American Pathologists. I'm Nick Lonnie. It's Tuesday, May 12th. The CAP has determined that the Centers for Medicare and Medicaid Services is making incorrect payment adjustments for some pathology providers. Some practices with high merit-based incentive payment system, MIPS, scores are receiving neutral or negative adjustments to their payments. If you believe your MIPS payment adjustment is incorrect, email the CAP promptly at registry.inquiries@cap.org. Swiss pharmaceutical giant Roche is acquiring Path AI, one of the leading developers of artificial intelligence tools for use in pathology. The deal expands Roche's use of AI in its diagnostic products. The two companies first started working together in 2021. The deal, which underscores the potential market for AI pathology products, could be worth more than $1 billion if specific milestones are reached. Next-generation sequencing, or NGS, could enable earlier, more accurate detection of cancer in bile ducts, according to a new study published in Gastroenterology. Researchers conducted a 6-year study of almost 3,000 specimens from more than 2,000 patients. NGS testing had higher sensitivity than traditional pathology, which has historically found it challenging to differentiate between benign and cancerous narrowing of bile ducts. NGS testing also found genetic mutations in about 20% of positive cases, which could help personalize treatment. And finally, pharmacogenomics involves molecular genetic testing to help determine how a patient will respond to certain drugs. It's one of the fastest-growing areas of personalized medicine and the subject of a new set of recommendations from a CAP work group. The recommendations were recently published as a paper in the CAP's Archives of Pathology and Laboratory Medicine. Dr. Ann Moyer, molecular genetic pathologist at the Mayo Clinic and a member of the work group, explains why the new guide was needed.
As laboratories enter this space, it's enough different than the rest of the molecular genetic testing that they might be doing. It's a little bit of a niche space. And so a lot of questions tend to come up from laboratories that they really want to do the right thing. They want to make sure that their testing is robust and it's going to help their patients. But since it's new, it's hard to figure out how do I go about adopting this? Like, what are the resources even that are out there? Because it's not necessarily something incorporated into people's fellowship training or medical training before that either.
The recommendations offer an introduction for labs new to the field, covering essential elements like test selection.
When the laboratory is developing its test, it has to actually decide, well, which variants am I going to even include in this test? So thinking about how do I decide what variants to put in the test? And then a lot of labs like to bring up multi-gene panels because that's something that their clinicians are asking for. So trying to figure out, well, what genes do you put in a panel? How do I figure out what evidence there is for some of these genes that are totally unfamiliar and in a new space? So just getting together some of those resources to help point people in the right direction was something that we thought would be really helpful and important.
The most prominent application of pharmacogenetics to patient treatment is testing for variants in the DPYD gene that can cause a toxic reaction to chemotherapy. But more innovative tests are emerging, including ones that make well-known drugs more effective, like clopidogrel for heart stent patients. Dr. Moyer is hopeful that pharmacogenomics will continue to improve patient care.
The thing that I personally am excited about and would really like to see is right now we're doing mostly genotyping, but I really hope to see the field expand to be doing more sequencing-based pharmacogenomics. And the reason I'm excited about that possibility is that means that we would be able to identify rare variants versus with genotyping, you can only detect the predefined variants that you were looking for. And I suspect a lot of patients out there have rare variants that we might be missing today. And so being able to incorporate those, I think will make our tests better over time.
That's all for today. See the show notes for more information on today's stories. And if you've got a story we should be covering, email us at stories@cap.org. We'll be back Wednesday at 5 a.m. Eastern for another episode of the Daily Edition. I'm Nick Lonnie. Have a wonderful day.